type of movable pulleys are used to increase the mechanical advantage. Now, all of you see this diagram of group of movable pulley. This is the first movable pulley. This is the X. This is the block of second pulley. This is the second movable pulley, which is connected to second string. This is the third movable pulley's block. This is the third movable pulley, which is connected with third string. And finally it is passing through this fixed pulley to change the direction of effort. Where the load is connected? In the first pulley, the load is connected. This is the load. This is the axle. This is pulley P1. This is pulley P2. This is pulley P3. This is pulley P4. Now, P1, P2, P3, P4. These are four pulleys. So, P1, P2 and P3, they are movable pulleys. Movable pulleys. And what is P4? P4 is the fixed pulley. Fixed pulley. So in this arrangement, how many movable pulleys are there? 3 movable pulleys are there and 1 fixed pulley is there. Now this is one string, this is second string, this is third string. So you can see 3 different strings are used. Suppose we talk about the string 3. If this tension is T and this tension is T, then you can say effort equal to tension T. Now how to calculate the tension associated to the load? In string 3, all the segment will have same tension because its mass is negligible. But this tension is supported by the addition of these two tensions, so that is equal to 2T. Since this tension is in string 2, so this is 2T, this will also be 2 because this is same string 2. Now these two segments 2T and 2T will give the tension 4T over here. So 4T is the tension in the right segment of the first string. So in the left segment will also get 4T. So total load which is attached, which is supported by the tension, equal to 4T plus 4T, that is equal to 8T. So effort equal to T and load equal to 8T. So what is the mechanical advantage? Mechanical advantage is load by effort, that is equal to 8T divided by T, that is 8. Now 8 means 2 to the power 3. Since there are 3 movable pulleys, so the mechanical advantage is 2 to the power 3. If we use only 2 movable pulleys, then the mechanical advantage will be 2 to the power 2. So, using a general term, mechanical advantage of n movable pulleys will be equal to 2 to the power n. Where n is the number of movable pulleys. Here you don't count this pulley. How many movable pulleys are there in this arrangement? 3 movable pulleys are there. So the value of n is 3 in this case. Now let us see velocity ratio. If the effort point travel a distance x, then in this arrangement, load will rise through a distance x divided by 2 to the power 3. So distance travelled by effort, if it is x here, then the distance travelled by load is x divided by 2 to the power 3. So the general term is, instead of 3 movable pulleys, if you are using n movable pulleys, then if the effort point travel a distance x, then the load point travel a distance equal to x divided by 2 to the power n. So what is the velocity ratio of this pulley system? Distance traveled by effort by distance traveled by load, x divided by x by 2 to the power 3, that is 2 to the power 3, which is equal to 8. Similarly, for n movable pulley system, if the distance traveled by effort is x, then the distance traveled by load is x divided by 2 to the power n. Remember, this is the general term, where n is the number of movable pulleys. So what is the efficiency? Efficiency equal to mechanical advantage by velocity ratio into 100. So we can get the efficiency in this case is mechanical advantage, that is 8, by velocity ratio, that is also 8, into efficiency. So total it is 100%. So this is the treatment you have to understand about n movable pulleys. As you see, the mechanical advantage in this case you can increase according to your choice. By increasing the number of movable pulleys, you can get desired amount of mechanical advantage. In block and tackle system, we use two groups of pulleys. One group is a group of fixed pulley and another a group of movable pulley. For example, we are first drawing a block and tackle system with 3 pulleys. So we are taking 2 fixed pulleys and 1 movable pulley. This is connected in this way. This is the fixed pulley and movable pulleys are connected in this way. Here is the load, here is the effort. This tension is associated to this effort. This is one tension, this is one tension, this is one tension. So total tension 3T support the load. So in this case, load equal to 3T, effort equal to T. So what is the mechanical advantage? Mechanical advantage of this block and tackle system is 3T by T, that is equal to 3. If the effort point travel a distance x, then the load will rise a distance x by 3. So in this case, if the distance traveled by effort is equal to x, distance traveled by load is equal to x by 3. So what is velocity ratio? That is x divided by x by 3. This is equal to 3. In a block and tackle system with n pulleys, suppose you are taking a block and tackle system with n pulleys. What will be load? That will be equal to n into t. What will be effort? That will be equal to t. So what is mechanical advantage? It is load by effort. So n into t by t, that is equal to n. Here the distance traveled by effort, if it is x, then distance traveled by load is x by n. So what is velocity ratio? It is distance traveled by effort by distance traveled by load. So x divided by x by n, that is equal to n. So velocity ratio in a 3 pulley system is 3. Velocity ratio in an n pulley system is n. So what will be efficiency? Percentage efficiency equal to MA by VR into 100. Here the result is 3 by 3 into 100. So it is 100%. Here efficiency, percentage efficiency equal to n by n into 100, that is equal to 100%. But practically, the efficiency of a machine cannot be 100%. How to understand why practically the efficiency cannot be 100%? Let the total load L is equal to small l plus w. This is the total load. This is the total load. which is the addition of actual load and resistance which is used, which is coming due to the friction between the pulley and the string, weight of the pulley, weight of the block, etc. So we have to overcome this resistance along with the actual load. This capital L by E, that is called ideal mechanical advantage, which is always equal to number of pulleys. And the small l by E, which is called actual mechanical advantage, and that will be surely less than the number of pulleys. Let us consider a block and tackle system with n pulleys. Suppose there are n pulleys. So for n pulleys, you can say ideal mechanical advantage, which is load by effort. What is ideal mechanical advantage? N. What is load? L plus W. What is effort? That is E. So this can be written as L by E plus W by E. So what is L by E? That is N minus W by E. So this L by E is actual mechanical advantage, which is less than N minus W by E. So we can say actual mechanical advantage is less than N. But what is velocity ratio? Velocity ratio is N. It do not depend on the resistance which we have to overcome along with the actual load. So the velocity ratio is equal to N. So what is the actual efficiency? Actual efficiency is given by actual efficiency. Actual efficiency is equal to actual mechanical advantage, which is N minus W by E by velocity ratio, that is N. So that is 1 minus W by NE you can write. So percentage efficiency is 1 minus W by NE into 100, which is equal to less than 100%. Thus practically you can see that due to this W term, we are getting the actual efficiency less than 100%.